Hello class. Today we are looking at Lesson 2, Systems of Equations. This lesson will cover how to solve systems of equations. You will learn techniques such as substitution, addition, or equations, and how to manipulate equations into two forms. Before we begin this lesson, turn to page 20 in your ACT Mastery Prep textbook, page 20, and look at 2.1 entrance ticket and complete the 3 statements that are given. Once you have completed the entrance ticket in your workbooks, go to page 21 and read over the 2.2 learning targets and complete the self-assessment. Let's go over a few vocabulary terms before we begin looking at the math notes. Equality. Equality is the state of being the same or equal, having the same value. An equation. Equation shows that two expressions are equal. And we know that when we look at an equation, we usually see an equal sign. You're solving for an unknown variable. Combining like terms. In an equation, combining like terms is the process of simplifying an equation using mathematical operations. Mathematical operations are adding, subtracting, multiplying, and dividing. Now look at section 2.3.1, equation elimination. And let's look at our example here. We have a system of equations, and I want to apply the elimination method, and it's sometimes called the addition method. Before I begin, what does the word eliminate means? We know that eliminate means we want to get rid of something. In this case, I want to get rid of one of my variables. I'm either going to get rid of the x or the y. Which variable is easier to eliminate, x or y? If I look at my system, I can say 4x plus 1x, that equals 5x. So I can't automatically get rid of the x. If I look at my y's, I have y minus y. I know y minus y are opposites, and I know the opposites equal 0. So y minus y will equal 0. So I can eliminate the y's. If I eliminate my y's, I am left with 5x equal 30. Now we can solve for x. To solve for x, I have 5 times x. The inverse of times is divide. So I divide 5 on both sides of my equation. What you do on one side, you have to do on the other side. Then I know 5 divided by 5 equals 1. I'm left with x equals 6. So now we have solved for x. We need to now solve for y. To solve for y, I want to plug 6 into x. I want to pick one of the original systems, one of my original equations to find my y. So I can either use the 4x plus y equals 14, or I can use x minus y equals 16. So just pick the one that's the easiest and plug in 6 for x. I'm going to use the second equation. X minus y equals 16. Plugging in, I'm going to substitute 6 for x minus y equals 16. We are solving for y. The opposite of plus 6 is minus 6. What I do to the left, I have to also do to the right side. 6 minus 6 gives me 0 because they are opposites. So I'm left with negative y equals 10. Right here, you can skip a step and just reverse the signs. What I mean by that is the minus sign becomes plus and the understood positive becomes negative. So my answer would be y equals negative 10. Also, we know that negative y is understood to be negative 1y. I can divide both sides by negative 1. I'm left with y equal negative 10. So my x is equal to 6 and my y is equal to negative 10. Sometimes you will see your solution written as an ordered pair. So let's write as an ordered pair. Ordered pair, we know that the first number is always my x and my second number will always be my y value. So my answer is 6, negative 10. That is the elimination method. Let's apply the elimination method to another system. With this particular system, I do want to line everything up vertically. I want my x's to line up, my y's to line up, and then my constants to line up. But I do notice I have a plus 4 on the left-hand side. To line up my constants, I want to move that plus 4 from the left side to the right. In order to do that, I need to subtract 4 on both sides. Now let's rewrite the system. I have 2x plus y equal 14. 3x minus y equal, we have 15 minus 4 gives me 11. Now we want to go back to our first example and think about what do we do there. Our goal is to get rid of one of the variables. We can either get rid of x or we can get rid of y. The easiest variable to get rid of first would be my y, because I know y minus y will give me 0. We're going to cancel these out. We're going to cross them out because they are opposites. What is left over? We have 5x equal 25. Now, from there, we're going to solve for x. Divide 5 on both sides of my equation. X equals 5. Now, we're going to go back to our original equation, and we can pick either one. And I want to plug in 5 for x. I'm going to pick the first one this time. I have 2 for x. I'm going to plug in 5 plus y equal 14. 2 times 5 is 10 plus y equal 14. I have y equal 14. If I move the plus 10 to the right of the equation, it changes from positive to negative. So y equals 4. Writing my answer as an ordered pair, I have 5, 4. This solution also tells us where does the two equations intersect. So when I see a solution here, this is one solution. 5, 4 tells me where the system intersect. We know intersect is cross, touch, interact. If I was to graph both of these equations, it will intersect at 5, 4. Now look at the next system of equations. Again, I want to make sure that my x's are lined up, my y's are lined up, and my constant terms are lined up. But this is not the case. Everything is not lined up. So before we begin to eliminate, we want to line these parts up. I want my first equation to look like the second equation. Notice x is first, y is second, and it's equal to a constant. It does not have to always be in that format, but it's easier to work out the problem seeing it in that format. I'm going to start out by writing the second equation first because it doesn't matter what order I write it in. And then I'm going to rearrange the first equation so it can line up with the second. Now, if I notice the minus 2x is on the left side, we want to keep it there. So because I kept it there, I don't change my signs. If you look at your equal sign, y is to the right. If I look at my equal sign here, this y is to the left. I want my y here to move over to the left. So to move it to the left, I have to change my sign. So we will have minus y here also. Equal. My positive 9 is on the left, and I want to move it to the right. It's to the left, and I want to move it to the right. So to do that, I have to change my signs and make it minus 9. Now, we have lined it up the best that we can, so we can see about eliminating now. I can't eliminate my x's, and this time I can't even eliminate my y's because negative y minus y is negative 2y, not 0. So I have negative y minus y. Thinking back to the previous examples, what must I do to make the y's go to 0? I need to change my signs. If I multiply either the first equation or the second equation, if I change all the signs on one of those equations, then I will have a positive y. You have to remember that when you're solving equations, what you do on one side, you have to do to the other side. So if I change one of the signs, I have to change all the rest of the signs too. I'm going to play around with my equation here. If I change all my signs, then I will get that positive y. So my minus 2x becomes positive now. My negative becomes positive now. And then my negative 9 becomes positive. So basically what I did was I multiplied everything by negative 1. And when I multiply everything by negative 1, all the signs change. Now we can revisit our system and look at our elimination. I can now eliminate the y's because y minus y gives me 0. So I have 5x, y minus y 0 equals 25. Divide both sides by 5. X equals 5. To find my y, I do want to go back into my original equations and solve for y. Which equation would be the easiest to find my y? Would it be the first one where y is already isolated? Or would it be the second one where I would have to move the 3x and the minus to get y by itself? The first will be our best one because y is already isolated. So I'm going to write y equal 9 minus 2x. I'm going to plug in 4x, which is 9 minus 10. 9 minus 10 give me negative 1. My ordered pair would be 5 for x, negative 1 for y. Look at our last example on the elimination method. First off, our x's, y's, and constant terms are lined up vertically, so we are good. We don't have to rearrange any of these equations. But I do notice that I can't cancel out x, and I can't cancel out y. One thing I need you to remember throughout this whole process was that everything looked the same except the sign. I had minus y, positive y. Everything was the same. That means the variable was the same and the coefficient was the same. Somewhat the coefficient, but the signs were different on that. You have to keep that in mind. The number part was the same, but the sign part was not the same. So right here, it doesn't matter which one I get rid of. I can get rid of x or y, but I need the number and the variable to be the same, but their signs need to be different. So I need to multiply by something to either cancel out the x's, or I need to multiply by something to either cancel out the y's. If I look at this problem, I know 3 minus 3 will give me 0. So 3x minus 3x will give me 0. Right here, it's a little different. I can multiply the first equation by 3 and the second equation by 2. And the reason I say that, because if I did y, I know negative 2. If I multiply by 3, I'll get negative 6. If I take the second equation, 3, and multiply by 2 this time, I will get positive 6. And we know 6 minus 6 will give me 0. So when you run across a problem like this, all you have to do was move my number here and multiply it to this number, and then take my number here and multiply to this number. And because the signs are already different, I don't have to play with the signs, because we always want the signs to stay different. So I can take the 3 and multiply it by the 2, and the 2 and multiply it by the 3 to get negative 6 plus 6 to get 0. So that's one way I can do that. Another way I can do this is I can go back to the x. We haven't done anything with the x's yet. We've just been working with the y's. So let's eliminate the x this time, do something different. We're going to say 3 minus 3. To do 3 minus 3, I have to multiply the left side and the right side by negative 3. In order to make the x's eliminate, I need to say 3x minus 3x. Now let's rewrite. We have 3x minus 2y equal negative 9. We're going to apply distributive property on the left side of the equation. Negative 3 times x and negative 3 times 3y. So I have negative 3x. Negative 3 times positive 3y is negative 9y equals a negative times a negative makes a positive 9. Now I can see that 3x minus 3x gives me 0. I am left with negative 11y equals 9 minus 9 is 0. Divide both sides by negative 11. The negative 11's cancel to 1. Y equal 0 divided by negative 11 is 0. So this time we found y first. Now we can go back and find x. Again, I want to choose the equation that has the x somewhat by itself. If I look at the original second equation, my x is somewhat by itself here. So I want to start right here to find x. Let's rewrite that original equation again. So we have x plus 3y equal negative 3. We have x plus 3. We're going to substitute 0 for y. equal -3. 3 times 0 is 0. So my answer is x equal -3. My ordered pair would be -3, 0. Remember, x is first and my y is second. If a problem looks like it would involve too much multiplying of equations or other algebraic manipulations, substitution is a good method to try. We know that substitution is to remove and replace in the same position. So we're going to now look at a few examples on substitution. Going back to that first example again, we're going to now apply substitution method. When you do substitution method, you want to figure out which variable would be the easiest to solve for. You have two equations. On this first equation, I think that the y would be the easiest to isolate. To isolate the y in the first equation, we're just going to say y equals, if I move the 4x to the right, it becomes -4x. And then bring down that plus 14. If you don't see a sign, it is plus. Now, y is isolated. Another thing I want you to also notice is that when I'm applying the substitution method, I write my system horizontally instead of vertically. So I put them side by side. That way I can go back and forth when I'm working out this problem. Now, I'm going to go to the second equation, and where I see a y, I'm going to remove the y and replace it with the -4x plus 14. We have x minus, be very careful with that minus sign, -4x plus 14 equal 16. Now, we are going to solve for x. Because I can see here now they only have one variable instead of two now. So now we can solve for x. I have x. I know a negative times a negative makes a positive. Plus 4x. I said negative times a positive is a negative. Minus 14 equal 16. We want to continue. We are going to combine like terms. So I have 5x. 1x plus 4x is 5x. I'm going to go ahead and say equal 16. That minus 14 is on the left side of the equal. So I want to move it to the right side of the equal. So the sign changes from minus to plus 14. I have 5x equal 30. Divide both sides by 5. X equal 6. Now, we have found x. If you notice, my y is already isolated, so I just need to plug in 6 for x to find y. Y equals -4 times 6 plus 14. And at this point, just type it in if you need to. We have -24 plus 14. My answer would be -10 here. My ordered pair is 6, -10. Now look at section 2.3.3 in terms of. And look at what we have written in our notes now. So it says, given the equations y equal c plus 3, d equal x plus 7, which of the following is equivalent to x plus y, written in terms of c and d? So what this means is I want my answer to say x plus y equal to something that has c and d in it. X plus y to equal something that has C and D in the answer part. So let's figure that out. If I'm trying to find x plus y in terms of C and D, I need to see what's the first step I need to do. Let's first start off by solving for x. If you notice, y is already solved for, so let's solve for x. Solving for x is just basically rewriting this equation in a certain way. We have x plus 7 equal d. I reverse the entire equation. X equal d. Move the plus 7 to the right to make it minus 7. Our next step, it says we want to write x plus y. So I'm going to do exactly what it says. I'm going to say x plus y. But we can apply our substitution. I know that x equals d minus 7. And I know y equals c plus 3. But if you notice on the left side, it has an addition in between the y, the x and y. So I do need to continue to put the plus sign on the right side and then substitute y, which is c plus 3. After that, I want to combine my like terms on the right side. My only like terms are negative 7 plus 3. I'm going to write d plus c minus 4. Now read the question again. It says we want to, which of the following is equivalent to x plus y, and I do have x plus y now, written in terms of C and D. If you look at the right side of the equation, it's in terms of C and D, because all I see is the variable C and the variable D. And I do see a constant, but we only pay attention to the variable parts. Now look at our last example of in terms of. It says if A equals B minus 2 and C equals A squared plus 4A minus 10, which of the following expresses C in terms of B? That means that I need my answer to say C equals the right side containing only the variable B in it. So when it says expresses C, I'm solving for C, but I want to see B in my answer. So C needs to be to the left, B is going to be to the right. I notice here that A is already solved for. If I look at A in the second equation, I can plug in B minus 2 everywhere I see A. When I plug in B minus 2, that gets rid of the A, and I only see the B part now. So I have C equal, everywhere I see A, I'm plugging in B minus 2 squared plus 4B minus 2 minus 10. After that, we're going to work it out. On the first step, we're going to FOIL, first, outer, inner, last. The second one, we're going to apply the Schroeder property. And then once we do that, we're going to combine like terms. As you can see, my base, I wrote out twice. This B minus 2 is the base, and I wrote it twice. Now I'm going to do FOIL. Now, we know FOIL is B times B is B squared. B times negative 2, negative 2B. Negative 2 times B, negative 2B. Negative 2 times negative 2 is positive 4. Then the Schroeder property, 4 times B is 4B. And 4 times negative 2 is negative 8. Now we're going to combine like terms. As you can see, I combine my like terms. So once I combine my like terms, I have C in terms of B. Now, look at your set 1 through set 5 on the next pages and complete those. Also complete your exit tickets and sum it up.